Good morning, good afternoon, everyone. Welcome to the second installment of CharIN Virtual Conference. I would love to welcome you to this event. It's very exciting. We had our first installment last week, and CharIN Tuesday was a great success. We learned a lot. We talked about very important issues surrounding e-mobility, and I hope we'll continue this conversation today. Next slide, please. So a few housekeeping rules to start. When you ask questions, please announce yourself and state your name and your company name so we know who you are and where you're coming from. It will help us to better answer your questions. Of course, you have an opportunity to type your question into the chat window. Our moderators will pick up this question and ask it at the appropriate time. And we also would ask you to wait with the questions until the Q&A session. Of course, you can pause them in the meantime in the chat window. That will help us to organize questions as we get to the Q&A session. With that, next slide, please. We would like to start our event officially today. My name is Oleg Logvinov. I am today's host and moderator. I work for IATECA. I'm one of the co-founders of the IATECA company, but today I'm here on behalf of CharIN as a member of CharIN North America board, and I'll be happy to help you throughout the event, answering your questions, moderating the discussions, and helping our panelists and moderators to do the best job possible so we can actually share with you something very exciting. First and foremost, let's talk about the agenda. Next slide, please. We have a fantastic day for you today. But before we start talking about the agenda of today, I would like to remind you what we have done last week during our first day. As you can see, we had a fantastic lineup of moderators and panelists. And the focus of our discussion was effectively on what is this riding of e-mobility wave means, especially at the times of coronavirus. And I think the main outcomes that we have taken away from the discussion last week can be the best articulated by the next slide. Next slide, please. It is really a stunning picture if you think about it. Erica from SIPA presented this very graphic visual. As you can see here, we are being hunted by the shark. COVID-19 is certainly a huge shark that is pursuing the whole humanity. But it is actually dwarfed by economic crisis that could be upcoming in the world. And if you think about climate change, that is really a monster shark in comparison. So while we're dealing with COVID-19 today, I think it's very important for us to remember that climate change is something that we cannot take our eyes from. And we need to work together to not only conquer COVID-19, but also conquer climate change that is definitely something that threatens the future of us as humans and future of our children and grandchildren. So I hope we'll continue to work together, and the purpose of our event today is to lay the foundation for that collaborations that will help us to address upcoming climate change. Next slide, please. So how do we do it today? Today, we will have effectively two demonstrations of plug and charge at work. You know by now that combined charging system and CharIN are very focused on enabling ISO/IEC 15118 communication between the car and the charger. And one of the key elements of 15118 is the ability to enable plug and charge. So our panel today is focused entirely on figuring out what does it mean for us to have plug and charge, how it's implemented, what technology goes behind the scenes, so to speak, to enable it, and how this technology is implemented so we can actually drive this vision of plug and charge forward. So the way we're going to structure the panel is quite simple. Bart Seidels from Object will moderate the panel, and the panel will start with two demonstrations. And after that, as usual, you'll be able to hear from panelists and have the ability to ask questions. So with that, I would like to hand it off to Bart. And Bart, you're welcome to introduce yourself and introduce your panel.
Great. Thank you very much, Oleg. It's a pleasure to be here and moderate the second day of the CharIN virtual webinar. As many of you know, this was actually supposed to be in person at Lucid facilities. Eric Bach from Lucid was able to give a bit of a background and introduction of the company. And CharIN is very focused on wanting to help test and facilitate interoperability standards for the further advancement of EV adoption and implementation of infrastructure to support this EV adoption. So as Oleg said, we've got an exciting day. This is the first part is focusing on plug and charge with a couple demos and then a panel. And then afterwards, there will be a presentation on the automated connected device use case of the standard. So next slide, please. So a brief introduction of what ISO 15118 is. This is in its most basic form, this is the open, interoperable, secure communication protocol that is the communication between the electric vehicle and the charging station. And so this is set the standard for being able to communicate various message sets done in a very secure manner, where the use cases that are used that are supported by the standard are done in a secure manner. But this standard is focusing exclusively between these two assets. And as many of you probably know, that there are additional protocols that are happening in between the car dealing with safety. And then there are, of course, other standards that are dealing with communication from the charging station back to the charging station backend, usually OCPP, and then other protocols around this whole process. So this is just focusing exclusively on this communication set. So next slide, please. With the standard, many of you know that this is something that has come out many years ago, and it started with a few different use cases being plug and charge and smart charging. But as it has evolved and international contributions by industry players from all different sectors, automobile, infrastructure, the mobility operators, they are providing input to the standard. And this is it shows a little bit of the growth and also the use cases. Plug and charge is what we're going to be covering mostly today. This is the amazing and most simplified EV charging user experience of just being able to take the plug it into the vehicle, and the charging session begins with automated authentication, so verification of who the car and the charging station are authenticated, creating a secure communication channel, authentication of the driver, and then authorization of the charging session, which means that you no longer have to have an RFID card or any other external identification means, a credit card. Use cases of the standard are also supported by smart charging, bidirectional, wireless charging, and then automated connected devices, which I briefly mentioned, which we'll see a video at the end of today's webinar supporting this. So with that, just giving a bit of the framework on ISO 15118, the power and the use cases that it offers, we're going to be focusing primarily right now on that plug and charge use case, which is the one that is really kind of out and about, real world implementations. We're going to hear from Cliff Fietzig from Electrify America, a little bit more of how this is being implemented and being offered to drivers in the very near future. So go to the next slide, please. And with this, advancing on with the day, I would like to begin the demonstration part of this webinar. So we've got two very interesting demonstrations, one that is focused a little bit more on the back end and fleet side, and another one on the charging station side. And so to open up the demonstration part of this, brief introduction I will just start with Mufi Gadiali from Electrify. Mufi, why don't you please introduce yourself and then go ahead with your demonstration, and then Mike will come on to you for your demo and presentation. So Mufi, thank you very much for being here. If you'd like to give a brief introduction of yourself, that would be great, and then you can continue on with your presentation. Thank you very much.
Thank you so much, Bart, and it's super exciting to be here virtually. I'll start off with a quick introduction, and then we can describe the specific use case that Electrify is working on. My name is Mufi Gariali. I'm the co-founder and CEO of Electrify. And if you can go to the next slide. Electrify is focused primarily on fleet operations, and so our use case is different from consumer operations in terms of how the consumer interacts with with charging in general relative to what a fleet would operate. And as you can see, and as we go through the slides into the demo, the fleet operations use case is actually very compelling in the context of 15.11.8 and plug and charge. And we believe that it's almost inevitable that 15.11.8 will become a core part of fleet operations. So in the next slide, we'll just cover quickly what are the different considerations as fleets are moving to electric. And one of the things that's very obvious is that all of the key elements are aligning for fleets to electrify. So one, the technology is here in terms of range and cost. The environmental benefits are very clear, and the operational ROI is beginning to make sense, especially in terms of maintaining and operating these vehicles. And a testament to a lot of the fleet deployments. Last year, Amazon announced 100,000 electric vehicles, and we believe that is the scale that's going to come in the next few years. In the next slide, we'll talk a little bit about what are the problems that fleet managers are facing. And so if you think about the perspective of a fleet manager, excuse me, they've been used to fueling diesel. And so vehicles come in, they fuel diesel, and they move out. But now they have to worry about a whole new spectrum of things, starting with what time the vehicle is charging, how fast the vehicle is charging, and how much energy is delivered. And this problem sort of exacerbates at an exponential level as more and more vehicles are added to the fleets. And we're talking about really large batteries in this case. So to give you an example, a transit bus has a battery size of between 400 to 600 kilowatt hours. That's roughly the amount of energy a single family home consumes in a month or a month and a half. And you multiply that by a fleet of a few hundred vehicles, and you can imagine the scope of energy management. Next slide. And what's also even more compelling and challenging for fleets is that the operational complexity is only going to increase over time, because now you have, on top of the energy management issues, you have things like dispatching, routing, the impact of weather conditions, the impact of the chemical aging of these batteries. So you can imagine that these fleets are being charged every single night or during the day, depending on the operation. And so the utilization and the charging rates of these vehicles are consistent and much higher than you would see on the passenger vehicle side. And all of this data has to be processed into something meaningful that can benefit the customer in terms of, improving their operations, logistics, balancing vehicles, and overall reducing cost. And this is where we believe that the 15.11.8 plays a key role in managing all of this data back and forth. The next slide will show a little bit about how we as Electrify build out this platform. So the way we look at fleet and energy management is platform services and applications and APIs. So our platform integrates into vehicles, into charging stations, into legacy systems that are used for routing and management or scheduling, and also into the energy and grid. And if you can see the common thread across this is there will be significant amount of data exchange starting from the vehicle itself to the grid and then back. And what is key in all of this is to have a secure platform that can manage the operations back and forth as data is being exchanged through all of these different entities or endpoints. So in the next slide, we'll cover a little bit about, go a little deeper into how we see 15.11.8 playing into fleet operations. And so the Electrify network is something that connects directly into the charging stations. In this case, it's OCPP 1.6 or 2.0 in the future. And we also hook into vehicles using telematics as that's available. And to manage charging across these fleets, the use cases is similar in the way a driver would interact in the consumer side. So the vehicle driver pulls into the charging depot to a particular charging spot, plugs in, and from that point onwards, we take on the authentication back to our platform services, where the contracts are being managed for each vehicle. And over time, as you can imagine, that as fleets start to scale, 15.11.8 will become a very key piece to our management capabilities, especially when you're managing large pools of vehicles and contracts across many different vehicles and many different entity types. So in the next slide, we'll cover a little bit about how we see 15.11.8 playing out. So next slide, please. So these are the key benefits. So the obvious ones are, of course, secure authentication. But for a fleet application, the smart grid and load integration also becomes a critical piece of this, because the key thing that fleets are trying to manage is how do you make sure that the every vehicle is charged and ready before it pulls out, but also how do you minimize the total energy cost. So specifically, how do you reduce demand charges, and how do you take advantage of time of use rates. But also, as these fleets scale, the provisioning and deprovisioning of these vehicles will become incredibly critical. And we see one of those, 15.11.8 being a key part of this. And then finally, from a fleet's perspective, as we are hooking into other systems, which could be dispatch management, routing, driver management systems, the ability for 15.11.8 to work across APIs and offer interoperability across many of these systems gives us a solid platform to build a lot of services in the future. And speaking of the future, I'll touch on just a few things that we see as the evolution beyond what's already there. So in the next slide, I'll talk a little bit about the things that we are thinking about as fleets grow to scale. And so if you can imagine, a fleet of thousands of vehicles, it's a new set of problems, because you're managing large pools of vehicles. And so we see the evolution getting into pools of certificates. And we'll talk a little bit about in the panel as well, is how do we, what are the complexities as large scales of vehicles show up for charging. There is also the notion of group contracts. So as the relationship between the utilities and the energy providers and the fleet operators change, how do we implement those changes in contracts on a scalable and a secure basis? And then finally, as vehicles show up in larger numbers. So right now, a lot of the projects, especially in the US, are between 5 to 10 vehicles, but they're quickly scaling up to hundreds and thousands of vehicles. And we see provisioning at mass scale becoming another key part of this. So I'm going to pause here and we'll switch over to the demo. And we'll quickly show you a few, basically a live view of how we've implemented some of these things in our use case. Now, just in full disclosure, we haven't fully implemented 15.11.8 yet. Our intent, when we started the discussion with Hubject and the rest of the team, was that we would show it at the CharIN conference in person, but because of circumstances, we've not been able to implement everything fully. So if you can start the demo, and I'll just quickly walk you through how this actually works out in a real implementation. So this is a live view of our dashboard, and as you can see, this is a depot where vehicles are plugging in, and the different colored states show the vehicles in different states. So for example, pink is when the vehicle is in a queue state. So the vehicle plugs in, and at that time, we get the vehicle ID, we get the state of charge, and we tie the vehicle to a schedule. So if you see on the side, these are the different elements that come into play into our system. So for instance, we look at all of the routes that are available in the depot. We also look at the utility rates as they are specified for each depot, so demand charges as well as time of use. And then we have an inventory of all of the vehicles that are deployed in the depot. And all of this data goes into our charging scheduler. So we look at the vehicle, we look at which route it's on, And then we use all of that information to tie back into our charging algorithm. So in this case, to be clear, we haven't fully implemented 15.11.8 yet. The mechanism we are using is auto charge. So by using auto charge, we can look at the ID of the vehicle as it comes through the CCS connector into our network, and then we authenticate the vehicle and start charging. All right, thank you so much, and we'll be happy to take some more questions during the panel.
Great. Mufi, thank you very much for that very interesting use for the standard and for the communication, obviously between the charging station and the vehicle, but the being able to help facilitate an important sector being fleets, as you mentioned. Amazon is committed 100,000 vehicles. There's plenty of other companies that are wanting to electrify their fleet. Auto OEMs, both legacy and new companies, are building vehicles that are going to support that from the vehicle side, both medium duty and heavy duty. So I look forward to exploring that a little bit more with you. Next, we have giving a demo. We have Mike Macaluso from IoTeca. Mike, welcome to the panel and the presentation. I kindly ask you to introduce yourself and then please proceed on with your demo and presentation. Thank you very much.
Thank you, Bart. So good morning, good afternoon, good evening. So my name is Mike Macaluso. I'm a co-founder and EVP of engineering at IoTeca. Next slide, please. So a little bit about IoTeca. So Oleg, who you've probably met previously and introduced our panel here today. Oleg and I are among the original inventors of PLC technology, which is one of the core technologies which is at the physical layer, communication between the charger and the vehicle, way back in 2005. At the time, we did this for data networking inside the homes, still popular in Europe, or a lot of these PLC adapters, more so in Europe than in US. We started working then with the auto OEMs early in 2010 to support all the aspects and low-level aspects of the PLC communication. So we've been in this industry for quite a while and been involved for quite a long time. And at that point, around 2010, we were acquired by ST Microelectronics, where we took the technology and built a integrated system on chip with home plug PLC and an application processor. So moving forward in time, around 2015, there was the launch of CharIN, and it became clear that there was widespread interest in not only developing simple chargers, or even at the time when 15.11.8 was being developed, it was being developed primarily for the purposes of exchanging telemetry for extending for the EV charging process to extend the charging controller outside of the vehicle. But it became clear that there was an interest in deploying smart and intelligent charging systems and doing a lot more than just a simple dumb charger. So as part of ST, we saw the challenges that our customers had and in assembling systems that would do the complete, be able to build the complete end-to-end system for charging. Knowledge of communications, system engineering, obviously electric vehicles, battery technologies, and charging were, among the things that were necessary, and also this new and emerging standard, 15.11.8. So this was, it took the industry a little bit of time to get moving. There are some complexities involved for sure. We also saw that there was a massive transformation that was just beginning. So two industries were, coming together: transportation, of course, and the electric grid. So we look here at the electric grid was not really built for what it will be used for. So we have the addition of renewables, such as massive solar deployments now, EVs that are grid connected with ever increasing batteries, and the addition of stationary batteries to the grid. And what was designed as a power distribution system, from generation to consumption, now really has to be is now considers millions of generation points. With solar, upcoming V2G, V2X, and all of these rather large batteries that are on wheels. So with all of these things, we felt that our team was well positioned to take advantage of that. And so in 2016, Ioteca spun off from ST and to become a standalone company. So next slide, please. So what does ISO IEC 15118N plug and charge offer, and what are the benefits to its constituents and the industry as a whole? So first, from the consumers, so looking at plug and charge, Bart mentioned earlier that one of the great benefits is you don't need RFID cards or apps or all of this being able to know what network you're on, and just that you can plug and charge. And it is indeed very, very simple. And with plug and charge, the goal and the experience is that you have an experience similar to that of a mobile phone. When you travel and you get off an airplane and you just turn on your phone, you don't really concern yourself with what cell tower it connects to, what network it's connecting to, what the service provider is, and what you'll be billed, because it's all part of your contract. There's all global roaming agreements that are done, and it's simple and seamless to you as the end user. And just like mobile phones, that wasn't the case when early on, and just like for EV charging, that wasn't the case early on, but it is now. And it also, plug and charge and 15118 also allow for special promotion consideration to be had by allocating and by understanding who the users are. And talking again about fleets now, as fleet operators, as we just heard, there's a lot of complexities associated with fleet management. So plug and charge and 15118 enable more of an effortless asset management. So taking some of the human component out of the process, because the process is getting more and more complex. It gives the fleet operators a huge benefit by optimizing their charging, taking advantage of maybe some simple time of use rates, or with V2G and V2X by redistributing energy between vehicles and being able to become participants in demand response and even peak generation at some point. And then plug and charge, of course, for secure authentication of the fleet vehicles, not requiring your drivers to manage credentialing, and to ensure that your depot chargers are only used on the vehicles that they're intended to be used for. So moving to automotive OEMs, so the OEMs can allow, the 15118 can allow for specific charging profiles for different vehicles, and also to receive from the charger over 15118 power availability and rates from the charger. So as far as what the predicted energy availability is, this is increasingly important if we're talking about systems where you have some, solar islands or other, maybe other vehicles, other V2X or battery storage, and also to communicate back to the charger from the vehicle what the predicted energy usage schedule of the vehicle is. And all of this helps make the user experience the best it can be. And really that's what we, from the automotive OEM point of view, obviously the customer experience is the most important, that charging just has to work. And all of this complexity needs to be abstracted out where it's not seen by the end user. And it also gives the automotive OEMs to develop extended diagnostics and additional value-added services. So if you look at employers, and very similar to fleets, you have the opportunity to use all of your vehicles in your parking lot for storage and demand response, and where this can be simply for management of local demand response, or participation in utility programs for demand response, and And in this case, the employers and the employees can share in the monetary benefits of these types of programs. And then lastly, but certainly not least, is energy companies. So energy companies will clearly benefit because they need to really harness the changing nature of their environment. Their need to be able to better manage these new loads that are coming onto the network at times that are not what they're used to over their years of operation, where we have, and in the case to even control some loads and also to take advantage of upcoming V2X support to have additional generation sources coming online. And the 1511A is really necessary in order to do that, because you need to coordinate the response. You want to keep the customer happy. You want to make sure the vehicles are charged to the level they need to be charged, and the grid then needs to understand what the capacity will be, and that will help allocate the generation and planning, and eliminate some of the very costly, more instantaneous response generation that's necessary at times. And then a common benefit to all is the security, and security is really a key. That the security is protected, just like that's used to protect bank transactions. So how do we enable this experience? So a full spectrum of elements are necessary from end to end. So from the cloud to the vehicle. So recognizing really the importance of 1511.8 as IOTECA, what do we do to enable our customers to move forward with this with this technology in a simple way? So starting from the vehicle, we have vehicle modules, EV modules, which manage AC and DC charge controller in a simple self-contained module. Moving over to the vehicle, to the EVSE. So we have several modules implementing really full scalable EVSE controllers, from simple protocol level session control all the way up to complicated systems. And then in between, very important, is a protocol analyzer known as the sniffer. It gives you the ability to see what's happening in a unbiased way, what's happening on the wire, to understand what's exactly happening, and to understand maybe where an issue could be, because without tools to debug problems, it's very difficult to make rapid progress on the development. Then on the other side of the EVSE, chargers need to communicate to more of a local controller, an edge controller. This is necessary to enable this whole ecosystem, so we can manage energy management, to be able to support power distribution where the supply feeder might not be able to support all of the maximum loads of what's connected. And then finally, IoTion, our cloud platform, which provides asset management to monitor, upgrade, do remote diagnostics. And all of this, including our platform, is integrated with Hubject system to monitor, or with Hubject system to enable out-of-the-box plug and charge support from end to end, with having to do very little extra in the implementation point. So we've spent years, IOTECA team has been part of the original Testaful events that have been going on for years now, and our customers can take advantage of this by saving time to use these robust solutions that are fully implemented and field proven. So with that introduction, I'd like to, in the following video, show you how all of this complex technology works, and really what takes place behind the scenes to, in the end, make this a very, very simple experience for the user.
ISO 15118 makes secure communication between an electric vehicle and a charging station possible. This protocol includes powerful interoperable features such as plug and charge, smart charging, V2G bidirectional energy flow, and wireless. The plug and charge feature enables an easy, secure, and convenient EV charging experience. All components need to be ISO 15118 compatible, like this ECS Leva smart charger with IOTECA's intelligent connected module. All stakeholders connect in a joint ecosystem. Hubject operates data pools and its V2G root PKI, which signs digital certificates needed for secure communication between the vehicle and charger. A Hubject signed digital leaf certificate and its V2G root are stored in the IoTeca module inside the Smart ECS charging station. Behind the scene, the V2G root certificate and a contract certificate are installed in the EV by the automaker. When a plug and charge session begins, the EV and charging station need to authenticate to establish secure communication. The charging station's digital certificate is encrypted and sent to the EV. The EV decrypts and authenticates the certificate, and a secure communication channel is established. Payment authorization for the plug and charge session is easy and seamless for the driver. The EV sends the driver's contract certificate to the smart charger for verification. The charging operator sends the contract account ID to the EV driver's mobility operator to confirm payment details. A response is sent back. Authorization is confirmed. No RFID card, no credit card, and no app is required. The charging session begins. ISO 15118 is a real-world solution for plug-and-charge, smart charging, and vehicle-to-grid on AC and DC chargers that facilitates interoperability and protects your investment for the future.
So thank you, everybody, and hand it back to Bart.
I think that I might be having a few technical problems. Mike, can you hear me?
Yes, we can hear you now.
Mike or Oleg, can you hear me? I think I might be having a few technical problems.
Yes, Bart, it seems like you have
Okay.
some issues.
I don't know if you can see me, but we'll keep my system up and running, but at least you can hear me. Gentlemen, can you see me now and hear me?
We can barely hear you and we cannot see you.
Oleg, and Oleg, would you be so kind to do the poll? We've got a couple of questions to set the stage for the...
But are you okay? Because we really have problems hearing you if Oleg takes over for a bit.
Yes, I'll be happy to do that. So we prepared a few questions for the audience because we thought it would be very interesting before we start the rest of the panel presentation to get some of the feedback from the audience. So why don't we display the first question?
Okay, sure.
And we'll give everybody a minute or so to reply to this question. First of all, we wanted to know where you're coming from, which industry segment you belong to. So as we've done it during the last event, as soon as we hit 50% on the response, Ricardo will tell us exactly what the numbers are.
Yeah, sure. Currently we have around 30%, so let's just wait a little bit longer.
Not a problem. Let's wait a moment, and as soon as we have more responses, as soon as we have 50%, we'll go to the next question.
Okay, now we hit the 50%. So 50% of the audience is working in the automotive industry, 27% in charging network infrastructure, around 10% in the government and university sector, 5% utility, and 10% software and technology.
Excellent. So let's go to the next question.
All right. So the next question is the following.
So once again, the story as last time, as soon as we hit 50% response, we'll tell you what the numbers are and we'll move forward.
Okay. That's definitely quicker. We already have 55%, but let's just give it a few more seconds.
Well, training always makes it better.
So, okay, hitting the 65% already, we see 73% working in the technology, R&D or engineering department, 5% sales, actually 0% marketing in here, 10% business development, and 13% policy and government.
Well, we just discovered the problem. We don't have sales and marketing people present in this event, which we need to fix. Some things that we need to address. Let's go to the next question.
All right. So similar to the one we had in panel 1, but maybe it changed. Have you ever driven an EV?
And let's see what kind of percentages we'll get here.
So remembering last time, I think it was only around 15%, but the question was, have they owned an EV?
Yes.
But this is a little bit different, and hitting already 60%, we see over 80% of the audience have actually driven an EV before. So
excellent.
That's
Excellent.
really good.
Let's go to the next question.
So then the question, do you own an EV?
And let's see a drum roll. So 80% of our audience today tried an EV. Now the ownership, it's a completely different story. Let's see, maybe we'll get a higher number today.
It's actually similar to the one in panel 1. We have 85% do not own an EV.
Well, a lot of work to be done by us. And Ricardo, I think it was the last question. Am I correct?
No, actually, we have 2 more questions.
Okay, go ahead.
So only for the people who own an EV.
So, do we have an answer?
So let's just give it a few more seconds. Obviously, not so many people will answer now, so I just stick to the 25% I have right now. And well, around 25% do not have any memberships. 30% have 1, 20% 2, around 20% 3, and 7% have actually 4 memberships.
Very interesting. And the last question?
Just about the thing Bart explained. Do you know if ISO 15118 is an open interoperable communication protocol? And we see we have a lot of experts in this panel. 80% knew it, 20% did not knew it.
Okay, so at least 80% knew that. That's fantastic. So at least for the remaining 20%, it wasn't educational. All right, so let's go back to our panel. And the next presenter on the panel will be Chris King from Siemens. Chris, the microphone is yours. And I would like you to start by introducing yourself and a few words how you got into this world of e-mobility, and of course, what you do at Siemens. Welcome.
Sure, thanks, Oleg. So yeah, I'm with Siemens. I'm SVP of Policy and Regulatory Affairs for our e-mobility business. I started working in e-mobility about 4 years ago, and when Siemens did not have a business unit, and Siemens has pulled that unit together As of a year ago, we just passed our first anniversary, although Siemens has provided products and services for many years in this space. So I came to this actually from the smart metering space. I have a lot of experience in that space. And standards was the big issue with smart meters, of course, and data management. So a lot of parallels within the e-mobility world to the space where I had been working before. Based in California with global responsibility here. So I want to talk a bit, just kind of remind us of the benefits of open standards, talk about what the evolutionary glide path is, how do you implement these things, and then talk about a couple of case examples, and we'll go to the next slide. So this is just a high-level view of what we do at Siemens. German marketing is not always the greatest thing. It's one of our best-kept secrets is that we have all of these e-mobility products and services, from the hardware, software, services, and so on. So going to the next slide, we'll look at the need for standards and what does interoperability give us and what does it really mean? When we do these customer surveys, range and charge anxiety are at the top of the list in terms of barriers to adoption. So of course the cost of the vehicle is number one, but number two is the charging infrastructure. When we say range anxiety, of course that's, how far can I go? But charge anxiety means, well, if I do find a charger, will I be able to use it? Will it be working? Will I be able to pay for it? Will my connector be able to connect to it? And so it's not enough just to have the charger. Will somebody be parked there? So I'll have to wait half an hour or more to get to it. So standards help deal with these in a number of ways. One is driving down the cost of this technology because you've got standard products that companies compete on. Second is a sense of future-proofing and lowering the risk of stranded assets because you have interoperable devices. So interoperability meaning, of course, that one device can connect to another device. A car can connect to an EVSE, or an EVSE can connect to a cloud, and so on. And this interoperability, this plug and play, gives customers choice and prevents vendor lock-in so that they can, choose different vendors for different elements of their system, and they can make those different choices over time. Next slide. And this is where we'll get into some specific case examples. And I really cover two things with this slide. And along the top, you see the progression there. And that's what we typically see in technology markets, right? Somebody invents a product and they've got a proprietary solution for both the vehicle and the charger in this case. Number of bus chargers in vehicles do that. As an example, of course, Tesla does that as another example. In the industry overall, companies realize that markets will grow more quickly and larger if you use open standards. So some companies, such as those who are on the panel today, are a great example of implementing 15.11.8. They start adopting these standards on a voluntary basis, and that helps grow the market. Regulators tend to get involved, when there's public policy issues. So that came up with mobile phones, right? In Europe, we had a standard GSM, which was adopted across the continent. Ended up having significantly lower costs than in the US, where we didn't have any standard. We had essentially 4 different networks, even more. And if you bought a phone from one of those networks, you were stuck with that network for the life of that phone. So in the charging space, we have seen some activity by the regulators, much more so in Europe and China than in the US. And then finally, there's this certification and harmonization element where you adopt a standard. It's one thing to say you've adopted it, but to make it actually work, it's got to be implemented in a harmonized way. So look at OCPP as an example, or even 15.11.8. It's going to be, the details of the implementation are going to vary from device to device initially. And so you get third-party independent certification of that, and you can overcome that problem. And then things really do become plug and play, and you get those results that you're looking for. So just a couple of specific cases I'll mention here. So in the US, we still have proprietary connectors. Tesla is an example of that I mentioned. Not that they're not a great company. It's not a criticism at all. It's just the way they're doing things. On the protocols front, we do most of the EVSE manufacturers, in fact, pretty much all of them, will provide OCPP in their EVSEs. But if you look at the market, 75% of the market for public chargers anyway does not use OCPP. So those chargers are not open standard. And then on the payment side, you've got to sign up with each of the network providers separately. Electrify America is changing that with their acceptance of credit cards. California has mandated the acceptance of credit cards, which is one solution. It works. It's straightforward. May not be the best solution. 15.11.8 actually over time replaces that need for a credit card, as we've heard earlier. Now, if you look at Europe, there's much more standardization. The connectors in particular, everybody has to accept J1772 as an example. On the protocol side and payment side, you have a lot more network operators in Europe, and most of them will accept customers from other networks. And you have this interoperability that's made possible by a centralized hub, which is Hubject, whose name has come up. And so each of the networks works with Hubject, and so they can exchange payment information. So as a customer, you don't have to sign up for each network. In the Netherlands, they have another universal solution, which has worked incredibly well, where the government provides the universal RFID card that all of the charging providers have to accept. So as a customer, you get this once, you're set up, you can go pay anywhere. You don't have that charge anxiety. If you can find a public charger in the Netherlands, you can use it. And then I just mentioned China briefly for completeness, where you do have government mandated standards. They're harmonized. It's very much a top-down system, so all of the chargers in China are standardized, so which definitely has a benefit. The costs are much lower there. You don't have this question of whether you can connect or not. But of course, that's not realistic in most of the world, certainly not in the US, to have those kind of mandates. So just to conclude, we'd like to see regulators promote and incentivize standards, but we don't like mandated standards. We don't recommend regulators pick particular standards, but they can provide some strong incentives. And with 15.11.8, one thing that the California Energy Commission is considering is whether grant recipients have to include 15.11.8 in their chargers when they receive those grants in the next round of funding. So that's an example of a voluntary case. Nobody has to ask for that funding or accept that funding, but if they do, then they may be obligated to implement 15.11.8 as part of that. So with that, I'll conclude, and I can move on from there. I'm happy to answer any questions.
Well, thank you very much, Chris. And I see that Bart is back.
See, this is the interoperability, making sure that everything works seamlessly. Even in mature markets, sometimes it doesn't always seem to work. So in a young stage and technology like electric vehicles and changing from internal combustible engines into electrification of a vehicle, see the challenges that we have, and I've got challenges of even Wi-Fi.
So, Bart, what you're saying is basically you're an old ICE and I'm a young EV, right?
Exactly. So, Chris, thank you very much for that. Oleg, thank you for jumping in. I'd like to invite Cliff Feetzik from Electrify America to say a few words. Cliff, please introduce yourself. Thank you very much.
Cliff Feetzik, Director of Technology at Electrify America. We were planning to do this all live and show charging and show ISO 15118 because on the Electrify America side, we're working heavily on moving all of the bits and pieces which we have seen in the previous slides into reality and rolling out ISO 15118 with plug and charge across our network. Can you go to the next slide? To give you an overview what that means for us, rolling out plug and charge to across our network. So our plan until end of 2021 is to have 800 sites across the US with over 3,500 chargers. All of the chargers are spaced in average 70 miles, or all of the sites, not the chargers, spaced in average 70 miles. Right now we see a maximum with a 120-mile range. And then all of the sites usually have between 4 and 10 chargers. So we want to really move the current network where we already changed the customer experience from you need to present your payment first and then you plug in over to plug in first and then present your payment, being able to do plug and charge. Because if the customer is doing it this way, plugging in first, then you actually have in the next step not providing any app or credit card anymore, then you can just walk away and the vehicle's charging. So showing here on that picture what we want to accomplish until end of 2021. Can you go to the next picture? Showing what we have today. Today, and this is a snapshot from a couple of days ago, we actually have 425 sites live. We have right now 114 sites coming soon where we already have the contracts and we're already working on, and the utility agreements are signed and all of that. So we are waiting for them for being opened with a total count of 1,559 CCS chargers. So all of these chargers will be able to support ISO 15118 with plug and charge. Why we wanted to use the testing symposium, which we were supposed to do this week out in California, to have this as a check-in point for us, also with all of the vehicle manufacturers and the charger manufacturers which we're using, in order to more or less do a sign-off and then go into a rollout phase. Unfortunately, we can't do that anymore because of COVID-19. So we are doing the testing right now in our lab in Herndon, Virginia, and we'll start in June, July timeframe. Let's see if we have a bit of a delay because we couldn't go to the lab for the last weeks with the rollout. And then since most of these sites where we have to roll out the software updates need a site visit, so we are planning between a summer and then an end of Q3, early Q4 to have visited every site to be ready for the plug and charge capable cars. We're working closely together with multiple vehicle manufacturers, and 2 are really close. So 2 will be able to use the plug and charge capability from the get-go to be end of this year able to serve all plug and charge and enabled vehicles with plug and charge in the market and across the US and across the country. So as we said, this was more meant as a demonstration in the setting at Lucid. More now a verbal account of where we are. So I will stay on for the Q&As. Really I can give you an insight on what it takes to do the development, the efforts on the interoperability testing. If you have further questions, then in the Q&As.
Cliff, thank you very much for that overview, and congratulations on the amazing implementation of the charging station and network that Electrify America has done.